The purpose of the slump test is to determine the consistency of the concrete. This is a measure of the relative fluidity or mobility of the concrete mixture. Slump does not measure the water content or workability of the concrete. It is true that an increase or decrease in the water content will cause a corresponding increase or decrease in the slump of the concrete, provided that all other materials and conditions are constant. However, many factors can cause the slump of the concrete to change without any change in the water content. You cannot assume that the water-cementitious ratio is being maintained simply because the slump is within the specification limits. ASTM C143 covers the standard practice for determination of slump of plastic hydraulic cement concrete, both in the laboratory and in the field. This test is not considered applicable to non-plastic and non-cohesive concrete. As with any hydraulic cement concrete testing, always wear the minimum proper protective equipment required. The mold shall be in the form of the lateral surface of a frustrum of a cone with the base 8 inches in diameter, the top 4 inches in diameter, and the height 12 inches. The test specimen shall be formed in a mold made of metal or plastic not readily attacked by the cement paste. The manufacturer or supplier shall certify the materials used in mold construction are in compliance with the requirements of test method ASTM C143. A rigid, flat, non-absorbent slump plate or board that is large enough to contain all of the slumped concrete must be utilized for this test method. In this video, we will demonstrate the slumping of hydraulic cement concrete with a metal mold and a slump board. This test method is applicable to plastic concrete having coarse aggregate up to 1 1/2 inch in size. If the coarse aggregate is larger than 1 1/2 inch in size, the plastic concrete shall be sieved over a 1 1/2 inch sieve and retained aggregate removed from the sample. The sample must be obtained in accordance with ASTM C172, sampling of freshly mixed concrete. Confirm that the slump board is level, moist, and free of vibration. Dampen the mold and the slump board. Complete the slump test from the start of filling the mold through the removal of the mold in 2 1/2 minutes. Fill the mold in 3 equal layers by volume. Fill the mold by moving the scoop around the perimeter of the mold opening to ensure an even distribution of the concrete. The first layer should be approximately 2 5/8 inches high. Incline the rod slightly. Rod the layer 25 times throughout its depth with the rounded end of the tamping rod. Uniformly distribute the strokes over the cross-section of the layer, starting near the perimeter, and progress with vertical strokes spiraling towards the center. Fill the second layer of the mold to approximately 6 1/8 inches high. Rod the layer 25 times uniformly over the cross-section. Rod through the layer and into the layer below approximately 1 inch. Fill the third layer and heap concrete above the top of the mold. Rod the layer 25 times uniformly over the cross-section. Rod through the layer and into the layer below approximately 1 inch. Should rodding the layer result in the concrete falling below the top of the mold, add concrete to keep excess above the mold. Continue the rodding count from the value reached before concrete was added to the mold. Strike off the top of the concrete with the tamping rod in a screeding and rolling motion. While maintaining downward pressure, remove any concrete which collected around the base of the mold during filling and strike off. Immediately remove the mold by raising it in a steady vertical direction. There should be no lateral or torsional motion of the mold while lifting. Lift the mold off the concrete a distance of 12 inches in 3 to 7 seconds. Immediately measure the slump. This is the vertical distance between the top of the mold and the displaced original center of the top surface of the specimen. Report the slump to the nearest 1/4 inch. If during the raising of the mold a decided falling away or shearing off of the concrete from one side or portion of the mass occurs, disregard the test and make a new test on another portion of the sample.